This is part 2 of a 3-part series for the Dynamic and Triggered Attributes section of the course, covering the use of SQL statements. In this section of the course, we will show how to use SQL statement queries and attribute properties to query and display data dynamically using the lookup tables created earlier in this course.
The benefits are more consistent and uniform data entry versus freeform.
SQL queries dynamically return value lists based on criteria.
The queries can perform calculations, sort, filtering, and even error handling for data. They require less ProjectWise Administrator configuration changes since they are driven by data. During this course, you will learn which attribute properties to use for lookup table data queries, the syntax used for lookup table data queries, techniques on presenting, limiting, and sorting the data, know the SQL statement limits, avoid complexity and pitfalls. To use the lookup table data created in previous videos, the properties of an attribute in a non-lookup table environment will perform what is called a select data query. As shown in this image, there are 3 sections of the attribute properties that can contain select type queries. We'll review those now. The default values property, you would use a query lookup table to assign a default value to the attribute. The query must return only one single value. For value lists, query the lookup tables to present valid selectable values. It can return one or more sortable rows of data. For the update values property, you query the lookup tables to present selectable values based on new criteria since the original selection list was loaded. This query returns one or more sortable rows of data. Let's look at the select data query syntax or structure for a lookup table. The select query is in the form of a SQL database statement. Let's review the syntax parts of the query. The SQL statement syntax used to perform a data query are select a column name from a table name where column name is equal to some value, and it can be ordered by the same or a different column name. So for an example of the lookup table document codes attributes that was created previously, we can use the keyword select and PW_originator_code to select those values from the lookup user attributes table where the ProjectWise _username is like the $user.name $. Now, $user.name $, is a system variable. We are using that as a criteria to locate the originator code for the current logged in user. Now, the breakdown of the lookup table query is the select is returning the values from a table column name PW originator code. The from database table named lookup user attributes. The where is where a column name PW_username is equal to some value, in our case, which is the current logged in user. Let's look at other optional parts that can be added to the select data query syntax to adjust how the data is delivered to the user. The present option is to include additional columns or characters to help users, such as using column_name plus the pipe plus the column_name to present the value and description columns to the user. We can also include upper or lowercase options to ensure the data is uniform for every entry. The limit option, we can include a top and then a number command to limit the rows to return. This is important for only returning a single value, such as for the default value. We can include a sorting, the keyword order by, to order the data. Let's look at the lookup table document code attributes example using present and limit options. First, we select and use top 1 to limit the very first entry, and we present ProjectWise _originator _code with the pipe character and the ProjectWise _originator. The user will see the code and the description presented at the same time. Now let's look at the lookup table general attributes example, which will use a present and sort option. We're using the upper keyword for ProjectWise code to ensure that all the codes entered are uppercase, and we're using the order by PW_sort order to ensure the data is presented in the order specified in the environment. Let's discuss more topics on SQL statement usage in ProjectWise, such as limits, complexity, and pitfalls. First, let's look at some of the known limits. One, there's 1,023 characters allowed for the SQL statement that will be stored in the default, value, value lists, and update value properties. Use shortened variable names and techniques to work within the 1,023 character limit. This version limit is based on the current release of ProjectWise and may be smaller depending on the version you are running. Another area to be cautious about is avoiding complex statements, which I would refer to as scripting. Complex statements can be identified when you're having to use multiple attributes and triggers to accomplish the task, when you're having to use unrecognizable variables and techniques used to stay within the 1023 character limit, when having to implement advanced SQL functions or multiple inner and outer join statements to accomplish a query, and when other ProjectWise administrators cannot understand what's happening when they try to read the SQL statements. Other areas to be aware of is to recognize the pitfalls that you can stumble into using SQL statements. One area is data type conversion issues. Understanding what data type your existing attribute is and the data type you're querying can be a challenge combining the two. Avoid use of single quotes or the tick mark for blank or null character checks. Due to issues with single quotes, it may be required to use 4 single tick marks to represent the 2 tick marks for a null character. Avoid copying and pasting from non-ASCII applications like Word or WordPad. The symbols used in Word and WordPad are not always the same ones that you intended to use. Ensure the query is not returning more values than the attribute can display. Using the select top 1 keywords can help avoid this, and understand there are differences between SQL Server syntax and ProjectWise select statement syntax, and we'll go over those here shortly. Let's look at an example of SQL statement code exceeding the limits of the table column used to store them in ProjectWise. This code combines multiple attribute values together with specific delimiters to make a document name. Even using shortened variable names, the code length is over 1,600 characters, which is way over the limit of 1,023. In this case, we are able to use an alternate coding method, replacing the select case statements with the if statement. By doing this, we were able to reduce the code length to 858 characters. So sometimes you may need to try to optimize the code using shortened names, but also alternative techniques. Here's an example of code complexity. The code is using multiple SQL techniques using the declare, select case, and when statements, which are supported SQL statements for ProjectWise. The intent of the code is to create the title block initials for the current user using the user description system variable by parsing it, providing a first initial, last name. As you can see in the code, there's a lot of parsing of string values, and the variability of a user having a first, middle, last name, or a hyphenated last name makes this code very difficult to meet all conditions. Another issue is that this requires all user accounts to have the same data structure and information stored within the user description property. Now, if we look at a much simpler solution for this, which would be to create a user lookup table with these values already populated, as we did in a previous section of this course, then query the value populated based on the user that's logged in. Here's another example of a complex solution using SQL statements. This is one attribute used to populate the current version number of the active document when a new version is triggered. In this scenario, there are multiple version formats, so the code has to determine which version format is targeted to be able to populate the correct previously used number for that version format. This is one of multiple attributes supporting this solution, as there are multiple formats. This is where it may be beneficial to investigate using a SQL stored procedure instead of a SQL statement. The use of storage procedures will be covered in the next session of this course. Here are some examples of the pitfalls previously mentioned. First, we're showing how to convert text to integer and increment the number. Knowing how the data stored in the attribute is very important, as simple procedures such as incrementing a number can be more involved than expected. Next is a common issue seen throughout form-based code entry when using the single quote character to represent a null or blank value. In ProjectWise Administrator, we are using two single quotes to represent a null value in the code. After saving, the two single quotes were converted into a single quote, which would cause this code to fail. It is best to use the null keyword in code versus using the single quotes when possible. If the use of two single quotes are desired, then you may have to use the technique of entering 4 single quotes, which will store 2 single quotes in the code. Last is understanding that SQL code generated in the SQL Server Studio Manager is not always simply copy and paste into ProjectWise. ProjectWise uses an ODBC driver to communicate with the SQL database, so the code written in SQL must be interpretable by the driver performing this operation. Some commands in SQL Server Management Studio won't work within ProjectWise, and there are some differences in the syntax for statements that are supported. As an example, one common syntax change from SQL Server Management Studio is not to use semicolons for multiple statements. Multiple statements in ProjectWise Administrator are simply separated with a space. Also, in SQL Server Management Studio, when comparing or assigning values, no parentheses are required. However, in ProjectWise Administrator, these parentheses are used to ensure the parts of the statement are not combined with other statements.
This concludes the second part of enhanced environments for dynamic and triggered attributes using SQL statements. Let's review what has been learned. We learned which attribute property to use lookup table data queries, the syntax used of SQL data queries, techniques on presenting, limiting, and sorting the data.
Know the SQL statement limits, avoid complexity and pitfalls.
The next part 3 of 3 for the ProjectWise Administrator Advanced Accreditation course will be for dynamic and triggered attributes using stored procedures. This section will expand on the advanced techniques for using SQL stored procedures for data queries and attributes.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.